Okay, we're going to do 7.2, graphing polynomial functions. The location principle, it sounds really complicated the way it's written. And it says, if f of a is less than 0, so it's going to be a negative number. So if f of a is a negative number, and f of b is greater than 0, so that's a positive number, then there is at least one real 0, that's the blank, between a and b. And the reason is, this is because there is a sign change in the f of x or the y value. So it went from a negative to a positive. If y goes from a negative to a positive, that means we've crossed the x-axis. Okay? So f of a is less than 0, so that's a negative number. F of b is greater than 0, that's a positive. Then we can say, then there is at least one real 0 between a and b, because we've crossed the x-axis. And here's how we would say this. This is because there is a sign change. We went from negative to positive, or positive to negative, it doesn't matter, in the f of x or the y, which means we've crossed the x-axis. If we cross the x-axis, remember what we learned. Crossing the x-axis means we have a real solution. There may be imaginary solutions, but at least we know we have one real solution there where it crosses the x-axis. Okay, so that's what that whole front part says. So let's look at number 1 example. It says determine the consecutive values of x between which each real 0 of the function, then it gives the function, is located. So we're trying to figure out where is it crossing the x-axis is the question. Okay, so here's f of x equals x to the 4th minus x to the 3rd minus 4x squared plus 1. We want to know, where does it change signs? Where does it cross the x-axis? Now, this is where, if you don't have a graphing calculator, I'm not going to spend the time plugging each thing in. I'm going to use a graphing calculator to do this. So I'm going to give you a table, and this is what I want you to fill in the table. We're going to go from -2. And what I would do here is I would put this into y equals, into my graphing calculator, and I would look at my graphing calculator. And then I would decide, well, what do I need to put on the table so that I can see all my solutions? Again, looking at the graph, we're looking to see where it's crossing the x-axis. And we're looking at it on a graphing calculator. So we kind of already have an idea where it's crossing, and now we're going to look at the table of values. Again, you could sit and plug each of these into the equation and get the answer. So that's 1, 2, 3, 4, 5, 6 different problems you'd have to do. Or I'm going to get out my graphing calculator, and I'm going to get second table to see the table after I put in this function. So here's what I got when I did this. 9, -1, 1, 3, -3, -7, and 19. And I'm going to look and see where are my sign changes. So between 9, in the y value, between 9 and -1, we had to have crossed the x-axis because we went from +9 down to -1, so this was a sign change. And we're going to figure out where that 0 is in a minute. We're going to figure out that solution. So that's a sign change. From -1 to 1, again, I went negative to positive. There's my another sign change. So I know I have a real solution there. Then I went from +1 to -3, another sign change. Now from -3 to -7, that's not a sign change. I'm still down in the negative, so that doesn't count as one of them. And here's my other sign change. So what does that mean? I have 4 real solutions here, and I need to figure them out. What are my 4 real solutions? Well, this is where I use my graphing calculator. I'm going to go to what I put my y equals, and I put my function in. And this is where I don't want to show this online. Actually, I may do a video on how to do this with your graphing calculator if I have time today. Okay, so what you're going to do is you're going to have to go to second, trace, and above that says calc, and you're going to calculate the 0. You have to do each one separately on the calculator. So I will do a quick video on using your graphing calculator. Okay, but let's continue. Let's do this. And I'll give you the answers on this because some of you know how to do this. And then if you don't, you can look at the other video so that we're not making this video like 20 minutes long. My videos are long enough already. All right, so let's put this on here. -2, positive 9, -2, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's up here. And then -1, -1. There's our first sign change. And then 0, 1, back up again. There's where we have another solution. And then 1, -3, again, another solution. 2, -7, this is not a solution, so that's 3, 4, 5, 6, 7, because we didn't cross the x-axis. And then 319, which is way up here somewhere. So it looks like this. It's going to be hard to draw. I'm going to do my best. Okay, it's supposed to be smooth. Okay, and then what we would do, and again, I'm going to use my graphing calculator to show you this on another video, and I'll add this. So the other video, we find our zeros, so where x, the first solution is x equals -1.44 approximately. This is going to be where x equals -0.57. The answer to this one, x equals 0.49. And then x equals 2.52. Okay, so like I said, I'll do a graphing calculator and add that to it for those of you who can't remember how to do this, and I'll try to show it exactly on the graphing calculator. That might help. Okay, the next part of the notes, it says relative maximum point, which no greater points have a greater y-coordinate. That's a lot to say. Find your relative maximum is where it's greater than anything else. Okay, relative minimum, the blank is where anything else is less. What we're looking for is peaks and valleys. Okay, we're looking for peaks and valleys. So maybe for relative max, you might want to put in peaks. We're going to look for the peaks. It may not be the maximum of the entire function, but it's a relative max. Compared to everything else around it, it's the highest point. And then when we're looking for relative minimum, again, it may not be the smallest thing on the graph, because some of these just go on forever, but then we're going to look for the valleys. Okay, where is our lowest point in that area? So let's do 2 problems like that. So number 2 says graph f of x equals x to the third minus 4x squared plus 5. You should have out your graphing calculator. So you go y equals, plug that in, and then look and see what we need to look at on our table. And what I looked at on my table was -1, 0, because that's where I saw my changes. That's where I saw where it crossed the x-axis. 1, 2, 3, and 4. Then I picked up my graphing calculator again. I already have this in. I already have the graph. So now to look at the table, I go to second, graph, and that'll give me the values that I want. 0, 5, 2, -3, -4, and 5. That's going to give me the basic shape of this graph. Okay, so let's graph it. Let's see if I can do a good job with this. Okay, so let's see. -1, 0, right here. 0, 5, 1, 2, 3, 4, 5. 1, 2. 2, -3. 3, -4. And then 4, 5. Back up again. Okay, and then I can kind of, I'm going to draw this best I can. And again, you do the best you can. It's supposed to be smooth. It's not supposed to be wiggly like it looks for me. I'm doing the best I can. We're going to look for our peaks and valleys here. Well, let's look for our relative maximum. Here's my relative maximum. So this is a relative maximum. and that's where x equals 0. So our first thing, our relative max in this case, that's one of my peaks, is that. There's only one peak really in this, and there's only one valley. Valley, yes, that's the word. In some, you're going to have more than one. So here's my valley, and my valley, I just figure out which part that is, and that's 3, -4. So that's my relative minimum. And what does x equal at my relative minimum? X equals 3. That's my relative minimum. Okay, let's look at one more. And again, if you're not sure about your calculator work, I will add a calculator video to this, or go look for the calculator video. F of x equals x to the 4th minus 4x squared plus 2. Now remember, that degree of this is 4, which means that the endpoints should be pointing in the same direction. Either they're pointing down or up. Now there could be things going on in between, but that's what our endpoints should look like. So again, I get my graphing calculator, I type in y equals, I put in that equation, and then I look at the table where it's most important. And I need to look at the graph to know where to go. So in this case, I see the important part is at between -2 and 2. That's where I'm deciding on my x's, by looking at my graph. I go to my table, second graph, I plug in my values, and now I'm going to graph it. Okay, so -2, 2, -1, -1, 0, 2, 1, -1, and 2, 2. This looks like a W. Okay, and if you've looked on your graphing calculator, you already have in mind what it looks like. Now this one has 2 valleys and 1 peak. Here's my peak here. That's a peak, right? So let's look and see what is that value. So I come over here, and that's at 0, 2. So my first peak, my relative maximum, is where x equals 0. Now in this case, we have two relative minimums. Here is the first one, and here is the second one. So we have 2 relative minimums. Well, the first one is at -1. So let's go here. It's this one. I'm going to cross over. That's my first relative min. And that's where x equals -1. And then my other one is where x equals 1. So I have 2 relative minimums here. And so you have to say them both. Okay? All right, so if you need some calculator help, go look for the calculator video, and that should help you.